Welcome back! Falcon 9 is all fueled up and ready to go, but there are a few things to cover before we hit the big red button. First is MechJeb's Ascent Guidance, which is pretty easy to use, but covering it will help both new MechJeb users and non-MechJeb using beginners alike. Ascent Guidance is an autopilot for launching your rocket to an orbit at a specified altitude. You'll want to be launching rockets to orbits above the atmosphere, of 70 kilometers or higher. In this case, we'll be launching to a 100-kilometer orbit. Because I have the Ferrum Aerospace Research mod on, which significantly overhauls the drag model and can cause rockets to be less forgiving during launch, we will tell MechJeb to limit acceleration to 25 meters per second. Let's go into the Edit Ascent Path tab and make sure that our gravity turn occurs at 10 kilometers or higher. That's above the heaviest atmosphere and lends more reliability to rockets when using FAR. With stock KSP, an 8.5, 9-kilometer gravity turn would be just fine. One of the things worth pointing out is that you can see the red line here denotes our flight path and is a long, almost logarithmic looking curve. It doesn't at all resemble the image most people have in their heads of rockets going up, does it? In fact, rockets mostly fly sideways, which must be quite terrifying when you're riding on one. Let's turn on the autopilot, which automatically throttles the rocket up and launch using the spacebar. One thing you'll note is that I did not activate the reaction control thrusters, small rockets that push the rocket to change its orientation, until after launch. The reason for this is that in KSP, if you throttle up your engine with the RCS activated on a pad, the RCS will try to lift your rocket off the pad, which wastes monopropellant, what they use for fuel. One of the main reasons for using MechJeb during this video is that I don't have to try and fly the rocket and talk at the same time, so by hitting M we can go into the orbital map, an extreme version of zooming out, and look at our target and our rocket's trajectory. Here is the apoapsis of our nascent orbit, which denotes the maximum height of our rocket's trajectory. Not yet formed is the periapsis, the lowest point in the orbit. It will appear when we achieve orbital velocity. Now you can see the beginning of the gravity turn, the most essential maneuver in achieving orbit. This maneuver harnesses the power of the planet's gravity to accelerate the rocket to near orbital speeds. The maneuver consists of gently turning the rocket 45 degrees at first, and then adjusting the angle as the apoapsis indicator, this reticle here, moves into position. You can also see that in the orbital view, our trajectory has begun to change dramatically. Where it first appeared as a high arc, as if one tossed a hacky sack into the air from one hand to the other, now it's becoming a long, curved, ballistic shape, like the arc of a gunshot. The natural instinct of beginners is to try and go as high as possible to achieve orbit. While it's possible to create an orbit in this way, it essentially is pitting your natural speed relative to the ground versus the distance from your rocket to Kerbin. So you'll only achieve an orbit when you get hundreds of kilometers away from Kerbin. You'll end up with a funky non-circular orbit, and you'll waste a ton of gas doing it. The gravity turn is definitely the way to go to achieve orbit. Now we can see MechJeb has created a maneuver node for our orbital burn. Maneuver nodes are tools that I didn't realize existed until well after I had landed on and returned from Mun for the first time, and even after I had sent manned missions to solar orbit. This means that if you find them confusing, you can still have a lot of fun and do a lot of things in KSP without them. However, they do become nigh essential for serious interplanetary exploration. We can see our node here, with its 6 axes, including burning prograde, which means to burn in the direction of your orbit, increasing your velocity, burning retrograde, meaning to burn against the direction of your orbit, decreasing your velocity, and 2 orthogonal axes, which I won't get into this video. Having said that, I would absolutely encourage viewers to play with the Maneuver Node tool. To do this, simply click on your trajectory and click Add Maneuver. This will create a node that you can then manipulate. Definitely explore how adjusting each axis adjusts your orbit. This will give you a much better understanding of the orbital mechanics in general, which is essential to you reaching other planets in KSP. You can also see the blue indicator on our nav ball, which is the direction required to burn for our maneuver, in this case for our orbital burn. The long yellow indicator is the front of craft indicator, and the lime green indicator shows us our heading and where to point to burn prograde. You can see the blue indicator and the green indicator are very close. We'll be burning prograde to increase our velocity to orbital speeds until a periapsis indicator forms and reaches the same height as the apoapsis. Also, at this point, we are well above the majority of the atmosphere, so we can go ahead and turn off the acceleration limiter. This will allow us to get into orbit faster. On the side of the maneuver node indicator are 2 green pieces of text: your estimated burn time and the time until you reach the node. In this case, We have to run our engine at full throttle for 1 hour and 26 seconds, and we have 44 seconds until our node is reached. Now, KSP assumes that you will complete a burn with the effective thrust of the last burn you did, and our rocket throttled down significantly before shutting off, so the number here is, needless to say, not very accurate. MechJeb will perform the burn automatically, but because KSP assumes that your rocket will produce all of its delta V in a manner instantaneously, it places the node in the middle of your burn, not where you want to start burning. Because of this, we want half of the burn to occur before the node and half after. So we want to start our burn at t minus half the estimated time and end our burn at t plus half the estimated time. This assumes that the estimated burn time is even remotely accurate, and here it is not. To achieve our 100-kilometer orbit, we need to achieve a delta V of 1,173 meters per second, on top of the delta V we've already spent. Now that we've started the burn, you can see the delta V meter going down. The red tab with the X in the middle here allows you to cancel the maneuver. Once it becomes green with a check mark, it considers the burn to be complete. MechJeb is very good at completing these maneuvers exactly, but when talking about interplanetary travel, the distances involved are so huge that you often have to adjust your trajectory even after MechJeb has completed the burn. Without MechJeb, the trajectory adjustments will be positively routine, even for simple things like achieving orbit or going to the moon. At this point, you can see that the apoapsis and periapsis are very close in altitude. We're now in a 100-kilometer parking orbit. Stay tuned for Part 3, Orbits and Transfers.